if you do not have any doubt, I'm happy that I presume that you followed. And let me just post another problem for you to think and answer. Maybe you're wise enough that you would say that which procedure that you would apply and solve, right? Let me put this problem. So I have here cylinder which weighs 2000 Newton, which weighs 2000 Newton. The cylinder is uniform cylinder which weighs 2000 Newton, represented by its plane along the weight, right? It's 2000 Newton. Is now making an attempt to go over an obstacle ahead. So this height of the obstacle is 15 centimeter, right? So there is a force P applied at an angle alpha to horizontal. And this application of force makes this cylinder just to go over this obstacle of 15 centimeter, whereas the radius of this cylinder R is equal to 60 centimeter. Right? If that is so, what is the magnitude of force P and the direction alpha? Or the smallest force P required? Determine the smallest force P and its direction alpha for the cylinder is to start just over the obstacle. So that's a question. So can you just answer this question? So this has been supported by the slope of angle 30 degrees. And you apply this force, you just have to go over this. So can you find out P and alpha? That's a problem. I will post this problem and shall we go to the next problem, or you will solve this problem first? Right. Did you get the problem statement? Determine the smallest force P and its direction alpha to horizontal for just to start the cylinder to move over this obstacle. And initially, the contact of cylinder with the slope is at this point. But when it just start to go over it, this contact has to lose. So you will not see a reaction here, and that is shifted to this point. So when there is no pressure on this obstacle and it is just supported, then there is no reaction at this point. But when it goes over it, the entire load is transferred to this point. So there is no reaction here, and there will be reaction at this point. That's a clue to draw the free body diagram. So what does that require? The direction of the reaction at this edge. So for the given state, and we are not looking at motion, it is just to start. Just to start, the word start just to over means it is in the static condition only. So only thing is this point now is point A and this point is point B. So you would have for this condition RA is 0 reaction, whereas you have RB. What is the direction of RB? For that I should draw this rectangle, this triangle. I'll just use this geometry. Because I know now the weight is acting down, So the weight of this is 2000 and P is at an angle alpha to horizontal. So the reaction is my third force and these two are not parallel. So this has to essentially pass through this point, this line, pass through this line. So I have along with this line force. So in this line normal I should find out. So the direction I should find out. So this direction theta here I can find out from the given geometry. Since from in this AP is what is radius, which is 60 centimeter, and this point is 15 centimeter. So let's say this point is D. So DB is 15 centimeter, right? I know what is point EP is 45 centimeter. This length. So opposite side is 45. Adjacent, this is what is this is OB. So OB again is equal to AP equal to 60. So I know OB, I know OE. So this angle theta can be found out as this is my 90 degrees, right? So what is that? I need to get theta opposite side I know, hypotenuse I know. So sine theta is what is equal to OE by OB. So I get opposite side 45 by 60. So theta will be tan sine inverse of 45 by 60. So what is the value I get? 45 by 60. Shift to sine inverse answer 48.59 degrees. That's theta. So now my free body diagram. My free body diagram is what? I would draw free body diagram. First my active force, it's weight, and then application of the force P. This is W, and then the reaction force. Now the direction of reaction I know this angle. So this angle is now theta. So this is already 30 degrees. So what would be my normal? What is my total angle? So this is my RB now. This free body diagram. So this free body diagram can be conveniently drawn as the last problem we discussed. Take W down, P in this fashion, and this is alpha, and this is W equals how much? 2000 given. This is P, and I have my RB. So the direction of RB is now to be understood. So direction of RB to EB is what we have seen. That is to the slope, this angle. So what is it to the vertical? What is it to the vertical? So this direction is how much? This angle is what I needed. So how much is that? How much is that? Anybody? So look at this problem here. So I require this line inclination to horizontal or vertical. So this angle 30, and you see this angle theta now we have got. So it's a bit geometry involved here. So this angle is 30. And if I draw here a line parallel to that alternative opposite side angle 30, so this 30 and theta minus that angle is what is its direction to horizontal. So I would have here my RB, this angle would be 48 point, this angle would be, say this angle is, say beta. So this angle beta would be 48.59 minus 30. So it's going to be 18.59 degrees. This is 18.59 degrees. Right? So now I can find out what is P. So I have these three forces. I can write my Lam's theorem, apply my Lam's theorem, and then I can solve for this problem. Do you understand this angle? How does it come? That angle comes from this geometry. So I have here this angle theta calculated, and that angle is the inclination of this hypotenuse of triangle OBE to EB, to slope. So, but now our slope is of 30 degrees. So, when slope is of 30 degrees from point B, if I draw a line parallel to horizontal line, so what will happen? Then I would have this inclination would be, what is theta minus that angle? So that is what is that you see here. So that is this angle. So now RB to horizontal I have. So I can now apply Lam's theorem conveniently and solve. So Lam's theorem now is another 2 minutes I will finish it. So 2000 by sine of angle included by other two vectors. So how much it is? Other two vectors 180 minus this minus alpha. So 180 minus 18.59 is 161.41. So 161.41 minus alpha, that's equal to T by angle included by these two, that's 90 plus this, so sine 108.59 degrees. That's equal to RB by sine 90 plus alpha. That's all. So now here I would be able to get what is my P. That's equal to 2000 sine 108.59 by sine 161.41 minus alpha. So this is my expression of P. What is asked? What is the smallest force P required? So P to be minimum, the condition is denominator of that should be maximum. What is sine of angle? Maximum value 1. So for sine of this equal to 1, and the angle 161.41 minus alpha should be equal to 90 degrees. So alpha will be 161.41 minus 90, which is 71.41 degrees. So the alpha, the direction of P here should be 71.41 degrees to have a minimum value. So that is 2000 sine 108.59 by 1. There. So it is 2000 into sine 108.59. That's equal to 189. So 1895.55 Newton is what is minimum force required. And then I can calculate what is my reaction, because I know now alpha, so 90 plus this, so I can substitute here. So RB will be equal to 2000 by sine 90. So RB will be 2000 by sine 90, and I substitute alpha into sine 161.41 degrees. That's going to be sine 161.41 this into 2000. That's equal to 637.6 Newton. That's the reaction. So this is how you would solve this problem. So here the understanding of stating that three-force equilibrium. So when I have here P and weight two concurrent here, and then reaction here comes, should go through that. That's the idea, and that lead you to find out its direction through this triangle geometry and so on, and you are able to finish the problem. So hope you have understood today's concepts of static equilibrium I would be happy that you never make a mistake and fumble to understand configuration diagram and FBD in the forthcoming classes. If you are good at it, mechanics is very simple, right? So with that note, I'm going to stop today's class and end my sharing the screen as well as stop recording.